the right-hand side of the equation. So if I square the left-hand side, I also have to square the right-hand side, which means I've got to square the 10. So the square root of x squared is just x, and the square root of 10 is 20, right? No, the square root of 10 is not 20. The square root of 10 is 10 times 10, 2 times, which is 100. Okay? So you solved a lot of equations. You solved two-step equations. You've solved equations with the variables on both sides. You've solved quadratic equations. But you have not solved radical equations. And that's something that we do in Algebra 1 and Algebra A and Algebra B. It's something that we do in B. And this is something that you've not done yet. Any questions about example 1? All right, example 2. Let's look at another radical equation. Bless you. The square root of v minus 4. So this time I want to show you something that has more than one term underneath the square root is equal to 3. The square root of v minus 4 is equal to 3. Well, I want to solve for v, and I can't solve for v because v is underneath the square root. So we're going to get rid of that square root, and we can get rid of all square roots by squaring the square root. So I'm going to square the left-hand side, and that's legal as long as you also square the right-hand side of your equation. Whatever you do to one side of the equation, you got to do the other side of the equation. When I square the square root of v minus 4, the square and the square root cancel each other out, and you're just left with v minus 4. 3 squared is 3 times itself 2 times, which is 9. And now you can solve for v because it's not under the square root anymore. Add 4. Final answer is v equals 13. Okay? You should not find the majority of this little section that we're doing very difficult. It's not very difficult. You just got to get the square root by itself. If it's not already by itself, then you got to square both sides and you got to perform the algebra correctly past that. Questions about example 2? All right, example 3. How do these get harder? Because we know they're probably going to get harder. All right, so here's one that's a little bit harder. -8 square plus square root 5a minus 5 is equal to -3. -8 plus big square root 5a minus 5 is equal to -3. All right, so we say example 3 is harder than example 1 and 2 because the square root is not by itself. So I'm going to put a little blue box around the square root just to show you that your square root is not by itself. So you can't square it yet. Okay? You've got to make sure that the square root is completely by itself. So why is it not by itself?
Because it's a 5. It's being multiplied by 5.
It's a -8's being added to it. The 5a minus 5 is all under the radical. So it's that -8 that's got to go so that square root can be by itself. So since that's a -8, we're going to add 8 to both sides. And then the -8 and the +8 will cancel. And then your little square root will be by itself. So then you'll have the square root of 5a minus 5 is equal to what? 5. -5 plus -3 plus 8 is 5. Okay. Now, since you added the 8 on both sides, now your square root is by itself. That was your job. You got to get it by itself if the square root is not by itself. Okay. Once that square root is completely by itself, that is when it is legal to square both sides of your equation. That's when it is legal to square both sides. You would not want to square the left-hand side if the -8 was still there. That would be a mess. So what's the square root of 5a minus 5 squared give you?
5a minus 5. 8 equals 6.
Just 5a minus 5. And 5 squared is 25. And Logan's already got the answer, and he's right. He says 6. I'm just not there yet. 5a is equal to 30. Matthew, would you please take these notes with us today? Divide both sides by 5. And a is equal to 6. Alright, so you'll have a few problems in your homework tonight where the square root is not by itself. Where it is not by itself. So that's what you would do in that problem. Alright, example 4. Here's another problem that starts out where the square root is not by itself. So example 4, negative 10 times square root v minus 10 is equal to negative 60. Negative 10 times square root v minus 10 is equal to negative 60. So if you think about that square root and you're asking yourself, is it by itself? Is it by itself? The answer is no, because it's being multiplied by negative 10. Nothing's being added or subtracted to the square root. Something's being multiplied times the square root. So we get rid of multiplying by negative 10 by
Adding.
dividing by negative 10. Division is the opposite of multiplication. Division is the opposite of multiplication. So if we're multiplying by negative 10, we've got to divide by negative 10. If we're adding 10, then we've got to subtract 10. If we're subtracting 10, then we've got to add 10. We've got to do the opposites. So the negative 10s are going to cancel, and you're going to get the square root of v minus 10 is equal to what?
Negative 50.
No.
Oh, that's what I missed.
Hey, what?
Negative 670.
Positive 6. Negative 60 divided by negative 10 is positive 6. Now once the square root is by itself, this is when you're going to square both sides of your equation.
Oh, they're being multiplied.
It's negative 10 times the square root of v minus 10. There's no plus or minus in between the negative 10 and the square root. Those are actually being multiplied times each other. Opposite of multiplication is division. When I square the square root of v minus 10, I just get what? When I square the square root of v minus 10, the square and the square root cancel out, and I just get v minus 10. 6 squared is 36, and my last step is to add 10. Final answer, 46. Alright, I have one more example for your notes, and that's all. 5 total examples. Alright, example 5. You will see some problems in your homework where both sides have a square root. So here's an example of where both sides of your equation have a square root. So this equation says the square root of 3n is equal to the square root of 4n minus 1. So what's going to happen most of the time is these two square roots are already going to be completely by themselves. There's nothing being added to either one of those square roots, subtracted, multiplied, or divided. So they're by themselves. So if you want to get rid of them, then you square them. And you're going to square both sides. So you can remove both square roots at the same time. Now when you get to Algebra 2, there's going to be some problems that are a lot harder. It's the same concept, but the algebra gets harder there. They're going to be pretty nice to you right now in Algebra B. And when you square both sides, both square roots are going to go away. So you're going to be left with 3n is equal to 4n minus 1. So the squaring of both sides removes both square roots And then all you have to do is solve the equation. So I've got a variable on both sides. What would be the best thing to do? Subtract the 3n or subtract the 4n?
The 3 inch, because it's the smallest.
Okay, it is the smallest, but in this situation, it's better to subtract the 4n, because if you subtract the 3n, the left-hand side goes to 0, and y'all usually just totally fall out of the boat and drown when that happens. So let's move everything over. Let's subtract 4n. 3n minus 4n is what? Negative n, and that's going to be equal to negative 1. Have I solved for n yet? No, I haven't. I need to divide both sides by that understood negative 1. Final answer will be
N equals 1.
n equals positive 1.